Sweet. Okay, so number 3, Jill rolls 2 dice and finds the difference between the number of dots facing up by subtracting the smaller number from the larger number. List the possible outcomes for one roll. All right, Jill. Let's see here. We are going to roll 2 dice and subtract the 2 dice from one another. So let's approach this a little methodically here. What is this? Do you want to do smallest or largest first? And, I can't actually hear you, whatever you just said, so I'm going to make my own decision. It reminds me of, like, Dora the Explorer. Like, do you want to do the smaller or the larger? Yeah, that's a great idea. I want to do the smaller one first. Okay, so the smallest difference is going to be, let's see, the smallest. If the numbers are the same, then there's no difference between them, right? So, I mean, if she rolls a 2 and a 2, then the difference would be 2 minus 2, which is 0. Okay, you can't get any smaller than 0 because you always taking the smaller from the larger. You can't do negative ones here. So the smallest number she will be able to roll is a 0. Okay, I'm sorry, the smallest difference between two numbers she'll be able to get is 0. Okay, let's think about what's the largest difference she could have. So what is the most different? What are the 2 most different numbers she could roll? Well, the 2 most different would be if she rolled a 1 and a 6. That's as far apart as you can get, right? So if she rolled a 1 and a 6, the difference there would be 6 minus 1, which would be 5, right? So the biggest difference she could have is 5. Okay? Now the only question is, do we fill in the ones that are between? Well, could she have a difference of 1? Yeah, if she rolled like a 4 and a 3, a difference of 1. Could she have a difference of 2? Let's see. Yeah, like a 3 and a 1. Okay. Could she have a distance of 3? Difference. Yeah, 6 and 3 would do it. Could she have a distance? My goodness, difference of 4? Yeah, I think so. And 5. Yeah. So there's a sample space right there, bud. That's all the possible outcomes. Now it doesn't tell us. Just so you know, because this isn't a multiple choice, I'll give you a little bit extra information here. Just so you know, these are not equally likely. All right? So if you actually worked it out, you'd find out, I'm thinking, let's see what, I think the difference of 1 is the most common. Yeah. And it's not very common to get a difference of 0. Even less common to get a difference of 5. But for my sample space, remember, it doesn't matter what my frequency is. I just want to know what are the possible outcomes. Well, we could have a difference of 0, 1, 2, 3, 4, or 5. All right. So going on to Jasmine. Shout out to Jasmine. Jasmine's history teacher keeps 2 prize boxes. Box A contains caramels and chocolate bars, while Box B contains homework passes and $1 coupons for the concession stand. When Jasmine earns a prize, she first flips a coin to determine from which box she gets to select a prize. If the head side of the coin is showing, Jasmine selects from Box A without looking. If the tail side of the box is showing, Jasmine selects from Box B without looking. Represent the sample space for Jasmine's prize possibilities either using a list or a tree diagram. One of these days I'll stop coughing, my goodness. Okay, Jasmine. Woof, what a story here. That was, man, is this English class or math? All right, what's going on here? Her teacher has 2 boxes. Box A, you can choose from if you flip a head on a coin. Box B, you can choose from if you flip a tail on a coin. Okay. All right, Jasmine. So it looks like she flips a coin, and then she reaches in and picks out of a box. So there's 2 events. It's a compound event. And I'm going to make a tree diagram because I like them. Here's Jasmine. First thing she does is she flips a coin. There are 2 outcomes. Either she gets a tail or she gets a head. Once she flips a coin, then she takes that box and she reaches inside of it. So box for H, for heads, it was box A. So she gets to reach in and she might get what? What's her outcomes from box A? She might get a caramel or she might get a chocolate. From the tails box, box B, she might get a homework pass or she might get a $1 coupon. Reminds me like when you get in the mail, if you're an adult and you get mail, junk mail, you'll get these like, you just won $10,000. off of, actually, I don't know, $10,000 coupons. That'd be quite a bit. But like $100 coupons. I'll get this all the time, like a debit card. $100. Free $100 off of a purchase of $5,000 or more. I'm like, oh, that's not free money. You had my hopes up for $1 here. It's not $1. It's $1 off coupon from the concession stand. Still pretty cool, Jasmine. Well done. All right. Also, while I'm rambling here, let's take a look. Notice we don't actually know the probability of getting a caramel or a chocolate, right? It doesn't tell us whether box A has more caramels or more chocolates. That's going to influence how likely it is she gets one of those two, right? So just something to be aware of. Maybe there's, in this side of this box A, there's 1 caramel and 200 chocolates, right? Or maybe they're 50-50. So we can't find exact probabilities of any of these events, of any of these outcomes. But we can draw our tree, which is what we did. All right, number 5. A bag contains cards numbered 1 through 5. There's only 1 card for each number in the bag. A card is selected at random, then a second card is selected without replacing the first card. Create a list of the possible outcomes for the card selections. All right, I'm going to create a list this time. Good, okay. We haven't done that yet, so it's good that we're doing that. Actually, you know what? I'm going to say, yeah, I'll make a list, but first I want to make a table because we haven't done that, this whole thing. And I just want to remind everybody how to do a table. So on my table, I'm going to do, there's 2 events. Event number 1, you draw a card. Event number 2, you draw a card. Okay, so here's my table. Event 1, draw a card. Okay, event 2. And this is an awesome strategy if you have only 2 events. If you have 3 events, like we had back with that Kevin choosing this car, don't do a table. It's going to be messy. I don't know how you can do it. Do a tree diagram. Okay, but here we go, 2 events. And there's my table. And your possibilities are getting a 1, 2, 3, 4, or 5. All right, so you can get a 1, a 2, a 3, a 4, or 5. Okay. And event 2, the possibilities are getting a 1, a 2, a 3, a 4, and a 5. So my table is going to look like this. Right now, it looks like it's going to have 25 cells in it because that's 5 times 5. But in actuality, this is what we call a dependent event. The second event depends, the probability of this one depends upon this one. Because, check this out, if you take that card 1 out of, you pick the first card, the card number 1, can you, and remember you take it out and you keep it out, is it possible for you to pick the card number 1 again? No, it's not. It's gone. It's in your pocket. You can't take it out of the deck again. It's not in the bag. And same thing with 2. If you took the 2 out, there's no way you can pick a 2 out again. It's not in the bag anymore. And 3 can't be taken out with 3. And 4 can't be taken out. If you take a 4 out, there's no way you can take it out again. And same with the 5. All right, so in actuality, I just took out 5 of these 25 squares. So really, there's only 20 possibilities. Okay, just so you know. In case it asks us to find probability, our sample space has 20 outcomes. And my list of them, if I want to write them down, well, it'd be 2, 1, right? 3, 1, 4, 1, 5, 1, 1, 2, 3, 2, 4, 2, 5, 2, 1, 3, 2, 3, 4, 3, 5, 3, 1, 4, 2, 4, 3, 4, 5, 4, 1, 5, 2, 5, 3, 5, and 4, 5. Whew. All right. So you can write all those down. That was it. Thanks for my friends for following along with me, for keeping up with the good pace here, and have a good weekend if you're done with all this. Awesome.